Okay, so the movie I did for this project is Speed. And to give a little background information about the movie, there's a bomb on the bus, and once the bus hits 50 miles per hour, it's activated. However, if the bus drops below 50 miles per hour, it will detonate. So they're trying to keep it above 50 and get all of these passengers off simultaneously. So for the first calculation, there's a scene where the bus is traveling down this open highway. It said that the construction was finished, but come to find out there's actually a 50-foot gap that was not complete. But in the movie, they show the track right before they actually have to jump the bus, and it's flat. There's no ramp, but in this picture, which is from the movie, the bus would have had to hit a ramp for the front of it to elevate like that. So what I'm wanting to find out is how far would the bus have actually dropped and not cleared the other side. So our known factors is they said in the movie that the jump was 50 feet, or that's about 15 meters, and then they were traveling at 67 miles per hour, or 30 meters per second. So our equation we're going to use for this is h equals 1/2 at squared. We already know a is 9.81, so we need to solve for t. And to do that, we're going to do the 15 meters divided by 30 meters per second and get 0.5 seconds. And from here, it's just plugging everything into this equation and finding that h is equal to 1.23 meters. So they would not have cleared the other side like they did in the movie. They would have dropped 1.23 meters below the other side and crashed into the highway below them. For the second one, they were coming off of the highway and onto a ramp that had a really sharp turn, and they were traveling at 50 miles per hour. And as you can see in this picture, the bus is off the ground on one side. So what the cop had everybody do was move from just being spaced generally on both sides of the bus and having everybody move to the right side of the bus to try and kind of have all of their weight on one side to keep the bus from tipping. So what I wanted to calculate was how much did that increase their magnitude of acceleration by having everybody move. So the equation we're going to use is v squared over r, and then to find r, that equation is v squared h over gx. And then for without it moving, our min would be 38.189. And since nobody moved, x is going to be set to 1. And with everybody moving, we'll have to resolve for x. But then replugging our min back into the magnitude of acceleration, we find that that is 13.08 meters per second squared. So now doing the part where they move everybody, we have to solve for x. And in one of our knowns on the previous slide, the bus width is about 2 meters. This took a little bit of research to figure out how to solve for this. So then we times it by a sixth and we get 0.17 meters. That's the change that happened with everybody moving. So we're going to add the 0.17 meters plus the 1 meter where nobody had changed. And so the total change is 1.17 meters. We're going to plug that back into the R-min that we previously found and found that it'll be 32.64. And then plug that back into the magnitude of acceleration equation and find that it is 15.30 meters per second squared. We're going to find the change. We're just going to do subtraction and find that it's going to be 2.22 meters per second squared is the actual change. Now, whether or not that's actually sufficient to keep the bus from tipping, I'm not 100% sure, but that's how much it did change by moving everybody. And then in their final scene, they got all the passengers off the bus except the lady who became the driver, Sandra Bullock, and then the cop. And so what they had to do is create this slide getaway. So they dropped the bottom of the floor of the bus, attached it loosely to one of the poles in the bus, and when they got on it, they dropped off, but they slid in the opposite direction. The bus continued forward, they essentially went backwards. And there was no other force acting on them, so really they should have continued in the same direction. So I'm just gonna find the momentums for each to show that there wasn't a change in direction. Some known factors: the bus weight, I just googled what that typical bus would have weighed, and it's about 38,000 pounds or 17,236 kilograms. They were traveling at 57 miles per hour. or 25.48 meters per second. I just made up this number for the people weight, which consists of the two people on that metal slide and the slide, and just said it has to be around 300 pounds. It could be a little more, but it's really not that big of a difference. It's not near the 38,000 pounds. And that's equivalent to 136.076 kilograms. So for the bus, we're just going to plug those numbers in and find that's momentum, and then do the exact same thing for the people. And so they have a significantly less momentum, but they would have still traveled in the same direction. There was no additional force that pushed them in the other way. They didn't push off of something or pull themselves in the other direction. So what would have happened is, in the final scene, the bus hit an airplane and exploded. That still would have happened, but they should have followed maybe at a slower time or at a later time, but they too should have ended up within that explosion.